Thank you very much for joining this session on tipping points, and particular thank you also to the Climate Exchange team for helping to organise this event and for running the Zoom account today. Our speaker will be presenting for about half an hour, and then there'll be plenty of opportunity for you to ask him some questions before we wrap up at 3 p.m. Please put your questions in the Zoom chat and I'll call on you to ask them once the presentation is over. But if you're unable to ask them yourself for any reason, then just make a note of that and I will ask them on your behalf. And also, just so you're aware, this session is being recorded. So without further ado, I'll say a few words about today's speaker. I'm very happy to introduce Professor Tim Lenton. Tim is the founding director of the Global Systems Institute and chair in climate change and earth system science at the University of Exeter. His research focuses on understanding the behavior of the earth as a whole system through the development and use of earth system models. He is particularly interested in how life has reshaped the planet in the past and what lessons we can draw from this as we proceed to reshape the planet now. His award-winning work identifying tipping points in the climate system has led him to examine positive tipping points within our social systems that could help accelerate progress towards a sustainable future. So thank you very much for agreeing to speak to us, Tim. I'll mute myself now and hand over to you.
Thanks, Lottie. Hi, everybody. I'll just get the screen share going. Yeah, you're seeing that okay? Yeah, great. So yeah, positive tipping points to avoid climate tipping points. The bad news first, and then I'm going to try and cheer you up with some good news, basically using the same concept to get us out of trouble that is also kind of explains why we're in trouble. And that's the idea of tipping points. So let me just show you a little movie to start with of a generic toy model of a system that is in one stable state, but there's another stable state it could be in, and the one it started in is losing stability, thanks to me, the modeler, destabilizing it over time. And at some point it's going to completely lose stability. On my computer it just did, and the system got tipped from one state to another. I might run it again actually. So basically, it's a toy model, a generic mathematical model here of could be any complex system approaching and passing a tipping point. But as we'll see, there's examples like this in the climate system and in social systems, and that's what the talk is about. And we might come back to the toy model partway through to see how there are early warning signals before the tipping point happens. But yeah, that simple kind of mathematical cartoon is a reasonable model for a whole range of tipping point phenomena in nature, ranging from bits of the climate and earth system in gold, on the often on the longest time scales and the largest space scales on these axes, through different ecosystems where tipping points are sometimes called regime shifts or critical transitions. So we've got blue is marine ecosystems, or aquatic ones at least. I think green is terrestrial ecosystems, and grey is a kind of things that the land-water interface. And then in red, lots of literature on and mathematical models of tipping points in social systems, both, well, bad, like civilization collapse, and, well, we'll see later on, some of them good. And it's the good ones we're going to need to avoid the bad climate tipping points in simple terms. So I'm not going to talk about things in Earth history that lurk right up here in the top corner, but I am going to start by talking about what was the Earth's long and hit it hard with. So this is the last 650,000 years as recorded in an ice core in Antarctica. So blue, the concentration of carbon dioxide in the atmosphere, but as trapped in tiny bubbles in the ice. And white, a proxy for temperature in Antarctica. Sorry for the lack of scale there, but it's about 4 degrees of warming from bottom to top in global warming terms on the temperature scale. And we're looking here at repeated ice age cycles. And as we come towards the present, they start to take on this very pronounced quality of what we call a sawtooth oscillation, for obvious reasons, hopefully. It looks like the teeth of a saw. Now, I like to say to people, well, if you took the labels off the axes and you just showed this trace to an electrical engineer or maybe to a cardiologist, and you asked them whether this was a stable system, they'd say, well, it's only really marginally stable. It's oscillating between bounds, but this sawtooth oscillation is the sign that, especially at the end of an ice age cycle, reinforcing destabilizing feedbacks within this system are taking over, and they're propelling the abrupt exit from ice ages. In other words, the Earth's climate was perhaps unusually unstable before humans started to really hit it hard. Of course, humans have been evolving in various forms through this interval, but we only really hit it hard recently. We've hit the CO2 level up to somewhere like there so far, 410 parts per million roughly. And in the rest of my lifetime, I think we're going to the top of the chart at this rate. And we should not be surprised if such a change compared to the backdrop would cause some fundamental tipping points in the climate. After all, the difference, that 4 degrees centigrade difference between an ice age and an interglacial, that corresponds to like 120 meters of sea level rise from ice sheet melt and collapse of major ice sheets, obviously. So yeah, I'm going to talk a bit more about what are the climate tipping points we need to watch out for, but just a tiny bit more about the past. This is zooming into the last ice age, just to tell you, if you didn't know already, that there's been loads of abrupt climate changes in Earth's recent history. So this is now a record from Greenland, a different ice sheet on the northern hemisphere, obviously, but we're seeing the record in a temperature proxy of repeated abrupt warming events as recorded in Greenland. These are called the Danskard-Oshka events, if you haven't heard of them. The warming is like 8 degrees centigrade in roughly a decade as felt at the place where the ice core is. But they changed the climate throughout the northern hemisphere, the tropics, and really around the world. And there's several of these convulsions, including at the end of the ice age. We zoom in a bit on the end of the ice age and then the exit into what we call the Holocene interglacial. Well, we might comfort ourselves that the Holocene, the last 10,000 years, looks a bit more stable than the ice age did. But it looks more stable in Greenland. But I'm afraid that if you looked at a record of like monsoons in the tropics, you'd see major switches on and off of monsoon systems, often correlated with these changes like this event here in the North Atlantic region. And those monsoon collapses and resumptions, they're often linked to the rise and fall of past civilizations. So still, the climate naturally is not a perfectly stable thing. And it's from this past evidence, that's one of the sources of evidence, which would give us some clues as to which bits of the climate system might be prone to being destabilized by our activities, principally fossil fuel burning during right now and for the rest of this century. So yeah, we could look to Earth's past to try and put things on this map that I published a while ago. And Earth's past would tell us that the circulation of the Atlantic Ocean has multiple stable states and can switch between them. It would tell us that the monsoon systems have switched on and off in the past. So those are big clues for why they're on the map. But we used two other sources of evidence to draw up this map. We used what do our models show when we run them into the future? Do the climate models show abrupt shifts in bits of the climate? And indeed they do. So models, some of them famously showed dieback of the Amazon rainforest as the climate changed in the future. Others showed dieback of the boreal forests. Others show collapse of the different ice sheets, Greenland, West Antarctica. And then you have our basic scientist physical understanding of feedbacks, processes that can give rise to really what we call strong non-linearity, or a tipping point where a small change makes a big difference to a system. So those are broadly the three sources of evidence that put things on this map. And you can see it's got icy things on the map, it's got bits of the biosphere, and it's got things to do with the circulation of the ocean or the atmosphere, or the two of them coupled together in the case of the ENSO phenomenon. I never thought the map was definitive. I put some question marks on there because, you know, we're less sure at the time that we'd got some of those things right. But interestingly, well, the map's evolved to have a few more things on it, but not too many things have got crossed off in the intervening 13 years. Anyway, that was a heads up to everybody a decade or so ago that there were these risks in the climate system. And when we want to talk about risk, we want to know, well, how likely are these events to happen? And also, what are their impacts? And there's been, as we'll see, a bit of work on the likelihood of different tipping point events, but there's been actually very little on the impacts. Suffice to say that we generally assume they would be large. So yeah, highest risk is the events that are likely and high impact. On the likelihood of tipping points, well, we've done all sorts of ways to get at that, but this is a look in climate models, basically, at where do abrupt shifts happen in the models as a function of global warming above the pre-industrial level on the x-axis. And it's interesting that there's a whole cluster of abrupt shifts in climate models starting about where we are now at 1 degree of global warming and happening before we get to 2 degrees of global warming. There would be a load more abrupt shifts at high levels of warming, but there aren't many model scenarios that go up this high. So you have to sort of picture for yourself a second hump here. But it's this little cluster here that's quite alarming. And that's one of the sources of evidence for this, towards this summary I'm going to give of changing risk assessment of the tipping points as a function of different sort of generations of IPCC report. So going through to two special reports, 2018 and 2019 are combined together down at the bottom. But yeah, the IPCC calls these events something slightly different, large-scale discontinuities in the climate system, which sounds like gobbledygook to most people, I suspect. But anyway, 20 years ago, when the first risk assessment was done for tipping points, the idea was, well, they don't become a serious risk until you get above 4 degrees of global warming. But now the alarming thing is we have plenty of evidence to say that the risk is significant already. We're already in the danger zone. And before we get to 2 degrees of warming, we're talking about high impact, potentially relatively high likelihood events. We're at 1.1 or for 2020, arguably 1.25 degrees C of warming. So we're definitely in the danger zone. And why would I say that? Well, not just because of models or something, but because we got observational evidence of things accelerating in the wrong direction, things that were on my map a minute ago from 2008, but now a decade more information, and we see fairly compelling evidence that parts of the West Antarctic ice sheet could have passed the tipping point. Certainly it's showing the dynamical response consistent with that. Irreversible retreat of some major glaciers that drain about the equivalent of 1.2 meters of sea level rise. Similar worries in East Antarctica, evidence of accelerating amounts of the Greenland ice sheet, slowdown of the Atlantic overturning circulation, Amazon rainforest, unprecedented droughts and fires, you name it. It's kind of an alarming picture, and I'm not going to try and dress it up as anything else. So that's why we are in a climate emergency and why we need to act as if we're in an emergency. It's even more alarming if you start to think about how different bits of the climate interact, because the way they causally interact, we're starting to see the evidence of that. And I'm afraid it's in a direction where tipping one thing makes tipping another more likely. So some people glibly call that domino dynamics for obvious reasons. You stick the dominoes on end, you push one over, the others tend to go. It's not quite that bad, but it's clear that the accelerated warming of the Arctic linked to the sea ice retreat is adding to the Greenland melt, and both of those factors are contributing to the slowdown of the Atlantic circulation. We know from Earth's past that that disrupts the monsoons around the tropics, and it leaves heat in the Southern Ocean and the Southern Hemisphere, contributing to the ice sheet melt down there. So that's why some of us kind of put a paper out a few years ago saying, well, whoa, you got to, we all need to wake up to this. Maybe, if the tipping points start knocking each other over, then if anybody's left to see it in a few centuries' time and they look back, they might just picture it all as one big tipping point to some other state of the planet with a lot less ice on it. And maybe we call it the hothouse Earth. You could call it the wethouse Earth or something. We can't say whether such a threshold firmly exists, and we certainly can't say where it is, but we can't rule it out. That's the crucial thing for our collective risk assessment. So having not been able to rule it out, we should be doing everything in our power to minimize the risk of that, a global tipping point. So just before I finish the bad news, one thing we've spent a decade doing is saying, well, can we get a better warning of when a tipping point's coming? And it's the same movie we started with, but now showing that before the tipping point, a system slows down in its recovery from perturbations, which you kind of can see by eye. I'll run it once more. If you're watching the ball closely, the ball is being subjected to stochastic noise. It's rattling around and rolling back quickly at the moment. It's going to roll back ever slower as we destabilize the state the system's in. And we pick up that phenomenon, it's called critical slowing down, with a statistical measure, the red line on the bottom plot. We can pick it up various ways, but I hope you can see it by eye. And that we've been able to show that there was consistent early warning signals slowing down of fluctuations in the climate before the end of the last ice age, which is what this example is about. We cut the data before the exit into the Holocene. It's some of the data from Greenland. You always have to detrend the data when you use these methods. It's not a perfect detrending. There are some issues, but when you just look at the fluctuations in the climate before the end of the ice age, it becomes kind of blindingly obvious that the system was destabilizing before it exited the ice age. And sure enough, we got the statistical measures to back that up. We can do the same thing in climate models. We can force them to have a tipping point and then examine in the model if there are early warning signals before it happens. And this is one example. It's a deliberately forced tipping point of the Atlantic overturning circulation in a fully coupled climate model from my mates down the road in Exeter at the Met Office. And basically, before we trigger the tipping point in the model, the fluctuations that are going on in the strength of the Atlantic Ocean circulation slow down and become more pronounced. And we can pick that signal up. We're picking it up here in statistical measures are autocorrelation in time. We can talk about that later if that's not a familiar idea to you. And variance is square of the standard deviation. That's hopefully fairly familiar. And then we've been looking at observational data, of course, to see if we see signals of this slowing down in bits of the climate system. And this is a study we published showing that one major climate index of variations in Pacific Ocean temperatures is showing the most amazing slowing down signal in the observational record. We have a few other papers submitted at the moment, including one showing pronounced slowing down of fluctuations of the Amazon rainforest biomass over the last roughly 20 years. So there's enough. There's some bad news. There's a clue to how we might get warning of what's coming. But we don't need any more bad news. I mean, you shouldn't need me to tell you that we have got to radically accelerate the rate of social change to avoid the climate crisis or catastrophe or whatever you want to call it. So let's talk about applying the same kind of thinking to the positive, find the positive tipping points we need to accelerate the change we need. This is work with Simon, who is based in the Cabinet Office and the COP26 team. So here's the task at hand. I hope you all know this already. We've got to get from ongoing rising greenhouse gas emissions to zero greenhouse gas emissions in one generation, in 30 years. That's spectacular rates of change in the global economy. We're nowhere near the required rates of change at present. The closest we are is probably in the power sector, where we're maybe a factor of 2 to 4 too slow in decarbonising. In transport, maybe a factor of 10 too slow. In steel making, maybe a factor of 1,000 too slow. So we desperately need to find some ways that the dynamics can speed up, and that's what tipping points are all about. So I'm not the only person saying this. There's a new literature just starting to emerge on, oh, hold on a minute, we've got to find social tipping points and social tipping interventions to get us from business as usual way of living to new decarbonized global economy, change relationship with nature, etc., sustainable way of living. But where are they? And can they happen? Well, here's a historical example to convince you that social and technological change can happen really fast. This is on the Easter Parade, Fifth Avenue, New York City, year 1900. Everybody is in a horse-drawn carriage. One person is in an automobile. And now we're going to look at the same parade in the same street in the same city 13 years later. Everybody's in an automobile, one person's left in a horse-drawn carriage. That's a major tipping point in personal mobility. It happened within a decade across the US. It's of course spread around the world. If you're curious, you might like to know that in the middle of the transition, about 30% of the early cars were electric with lead acid batteries at the time. Unfortunately, partly linked to some conversations between Thomas Edison and Henry Ford, we ended up with the Model T, the internal combustion engine, and the rest is history. Anyway, that's not the only, obvious evidence of abrupt change in technology in the past. Here's a load of curves showing abrupt uptake of new technology. And more importantly, we need to think about, well, what are the well-known reinforcing feedbacks that can propel positive tipping points of abrupt social change? Well, they're kind of familiar. Everybody's heard of learning by doing. The more we make something, the better we get at making it. Everybody's heard, hopefully, of economies of scale. The more we make something, the cheaper it gets to make. And maybe there isn't a good name for this, but I call it technological reinforcement. When a new technology emerges, the more it's used, the more other technologies emerge that make it more useful. So we'll come to it, but think of electric vehicles and charging networks or many other examples. There's a social side to this though, right, as well, which is a phenomenon that academics call social contagion, or that's one of several phenomena by which new norms or new behaviors or the uptake of new products can spread like wildfire or like exponentially through a population. In the simplest form, just because people imitate each other and they imitate their neighbors. And in today's network world, our neighbors are not necessarily the people on the same street as us. They're in a sort of virtual neighborhood of the internet. Anyway, it actually works for neighbors on our streets, and it works for some sustainable technologies. So solar panels on the roofs of houses has shown social contagion. Here's a little movie to illustrate that. It's 2012 to 2015, looping round. It's part of Colorado in the US, where there was this incredible social contagion of uptake of PV on roofs. Not the only place where that's happened. The other technology for which it's clearly happening at the moment is electric vehicles. And that's my other good news story. We have clear evidence of a tipping point for the uptake of electric vehicles in where Norway is leading the world, for reasons you can ask me more about in the questions. But I plot here with Simon on the x-axis the difference in cost at the garage if you want to buy it, I mean at the showroom, between an electric vehicle and a petrol or diesel car, and on the y-axis the market share of the electric vehicles. And it's spectacularly non-linear, right? You get very close to zero and still it's only 5% uptake. You get to price parity and suddenly Norway, actually the data's old here, Norway consumers are buying 2/3 electric cars at the moment. And interestingly, the Netherlands in December 2020 suddenly had 60% EV sales. So clearly they were close to the tipping point. Now, why is it cheaper in Norway, the electric car, or the same price? Because of a whole load of subsidies and incentives. But the good news is electric cars are going to be cheaper for everybody within about 3 years. And that's because of economies of scale. It's because the bit that's been adding the biggest sort of chunk of price in some ways to the car, the battery, the price of batteries is coming down the more batteries we make. And it's coming down this fantastic cost curve. So that's the green bar on the bottom plot, adding to the cost of the electric vehicle compared to the internal combustion engine vehicle. And you see, you know, pick your projection, but the one from Bloomberg says around 2025, basically electric cars get cheaper to manufacture than petrol or diesel cars, at which point they're sure to be cheaper to buy. And you'd be crazy not, if you needed a car, you'd be crazy not to buy one in many ways, because they're definitely cheaper to run. So that's good news. And I'm excited about it because it opens up the opportunity for other tipping points. So just as tipping points can cascade in the climate, and that's a bad thing, the hope I've got with Simon is they can cascade in the economy, and that could be a good thing. And the cascade that we sketch out here, we've talked about the first tipping point that's coming, but once it's happened and we have this massive scaling up of electric vehicle manufacture and battery manufacture, then batteries are going to keep plummeting in price, and that's going to open up opportunities for all these other tipping points. Like my favorite one is actually this one here. Cheap battery storage is really great for renewable power generation, because the big problem with renewables is supply and demand imbalance. The wind, when the wind's blowing and the sun's shining, is not necessarily when the demand is for electricity on the grid. So you want a cheap form of storage to iron out the imbalance. And what better way than with cheap batteries or with lots of EVs plugged into the grid? And that brings me to a second good news story, a second example of a positive tipping point that's already happened in our own inglorious nation. We have managed to shut coal burning out of power generation in the UK in less than a decade, the royal we. How did that happen? This is a little bit of data sort of showing the first tipping point, but it's a bit complicated. But basically, a few things are going on. As taxpayers, we've all been investing in renewable power, which is, once you've paid for it to put the installation in of offshore wind or whatever, is generating electricity cheaper than anything else. Then usually coal would be the next cheapest thing to burn for electricity. But thanks to a price on carbon emissions in the power sector, a tipping point was crossed where instead of burning coal, we switched to burning gas. So that's referred to as the coal to gas switching price. It's the red line here, compared to the EU's price on carbon emissions is the grey shaded area, and blue, crucially, is a deliberate price, extra price on carbon in the power sector, levied by the UK government and stepped up somewhat deliberately over time, that got us to this kind of tipping point, price tipping point in about the end of 2015. You'd think that that was kind of reversible. The fluctuations in these prices are happening all the time, but what it did is it changed investor expectations, and plenty of people who were invested in coal burning suddenly realized they weren't making any money, and they got out of it pretty quickly in a financial sense. So the economics of coal went bad. And that's why coal power then nosedived. It's the black line here. So it goes from about 40% of power in the UK 2012 to about 0 as of now. And the renewables have picked up most of the slack. And the transition's irreversible, because once the economics of coal went bad, well, coal-fired power stations like this one in Didcot in Oxfordshire got destroyed. So great news as far as I'm concerned, and we should be proud of that. Those of us who have any national pride left, that we've done one good thing for the climate. And we, of course, want this to happen globally. And the good news there is economies of scale again. Solar PV in particular is getting spectacularly cheap, and it's continuing to get cheaper the more of it we deploy. and some experts say it'll be generating electricity at a fifth of the price of any fossil fuel burning within a decade, which is totally spectacular. And it's already true as of a year ago that if you take out the perverse subsidies still present for fossil fuel extraction and burning, renewables are generating electricity cheaper over most of the world. Yellow is the places where PV is cheapest, blue is where wind is cheapest, grey or black is where the fossil fuels are still cheapest. That was a year ago. It's looking even better right now. So the tipping points are here, or they're coming for power. We're pretty, as I've just shown you, we're kind of at what's called the new for new comparison tipping point, where new renewables are cheaper than new coal and gas. And the more we deploy renewables, the cheaper they're going to get. That's those economies of scale. And that's going to drag us to tipping point number 2, where it makes economic sense to shut down a power station burning coal or natural gas with useful life left in it and replace it with brand new renewables. And that's coming, say, within 10 years in China, and other major emitters are sooner than that. So these positive tipping points are what we need, and I hope I've shown you some evidence that they're here or they're coming, and they interact with each other. Like I said, these things can cascade in a good way, and I already told you that, you know, cheap batteries is fantastic for clean electricity, renewable electricity, which in turn is obviously the best thing to power electrification of transport, which is then making the batteries ever cheaper and cheaper, which then opens up all these other avenues for decarbonising the economy. Happy days, or hopefully happy days. So yeah, there's a summary. Climate tipping points, bad news, folks, major risk. We've got to avoid them at all cost if we can. And the only way we're going to do that is to radically accelerate the rates of social, technological change that are going on around us. But hopefully I've shown you that it's not a hopeless case, and there are some real examples of that already happening. Thanks a lot.
Thank you. And I'm sure that we'll have a lot of questions that will be popping up in the chat. Just to remind everyone, this is being recorded. But if you could please put any questions in the chat and I'll call on you in order. But I will selfishly kick off with my own question.
What's that?
Which is, we did a module about mitigation last term and talked a lot about carbon budgets. Mm-hmm. And you see companies who say that their emissions reductions plans are in line with carbon budgets, things like that, or their share of the carbon budget. I'm wondering how you reconcile tipping points, which obviously have such profound on carbon budgets. I know that they can have sometimes my lack of understanding of climate science, but seemingly arbitrary allowances for unrepresented system feedbacks. I think they call it.
Yeah, I think you're spot on, Lottie. I mean, we don't, like everything in this problem, we don't know the carbon budget to stay within 1.5 or within 2 degrees C precisely. Do we know it approximately? Yes, but we might be wrong by quite a big amount, and we're quite open in IPCC that whilst we might say the budget, for the sake of argument, let's say the budget to stay within 1.5 degrees C might be 350 plus or minus, possibly minus 100 billion tons of CO2 if permafrost continues to thaw at an accelerating rate and release carbon to the atmosphere. So I'm sure these companies took one figure for the global carbon budget, and then somebody did a heroic divvying up exercise to give them their allocation, and there's much to discuss in the politics of such an allocation. But yeah, rarely have I seen a conservative sort of error bar on those. So I have published something, interestingly, with a researcher who I think is Imperial affiliated at the moment. That was around, can we get past naive measures like global warming potentials and actually incorporate tipping point that's why I've chosen to work on the positive tipping points, because it's not achieving anything, just worrying more, and sometimes it paralyzes you, as you're suggesting, and you are awake at night. I think it would be a disruption of the monsoons, actually, which we saw some evidence of, certainly for Indian monsoon in recent decades. That could happen really fast, and it could hurt an almost unimaginable number of people. So yeah, plenty of things to keep one up at night, but I'm trying to stay asleep at night by focusing my energies on shifting to working on these positive tipping points. Yeah, because we could get lucky. That's the great thing with the tipping points and the uncertainty. We could get lucky, but our only chance to get lucky is to change ourselves rapidly, or our societies rapidly.
Thank you. Our next question is from Katie, and again, she cannot ask, so I'll ask on her behalf. She was wondering if you could talk more about the climate change induced ozone hole. Yeah, and how that might occur.
Interesting one, Katie. Yeah, you probably also spotted that the original Antarctic ozone hole was on our map, even though it's not a wholly climate thing, obviously. So the idea of a climate change induced ozone hole in the northern hemisphere, that might be one of the ones I might take off the map now, interestingly, but when I was writing in 2008, it was a possibility. Quite a complex story. I mean, you might first of all ask, well, why was there an Antarctic ozone hole and not an Arctic one? Why wouldn't it be symmetric? Well, it's not symmetric because the circulation of the atmosphere is not symmetric, and you have a much stronger what's called polar vortex over Antarctica, because you kind of have a continent that's kind of centered on the pole, and then you have an ocean around it, and everything spins around the ocean circulation, the atmospheric circulation. And the polar vortex matters because it can maintain very cold air at altitude and things called polar stratospheric clouds, upon which the critical nonlinear catalytic ozone destruction chemistry turns out to happen. So we all know that CFCs or HFCs are kind of the problem, but they don't do it. But the ozone hole is a nonlinear phenomena because of this catalytic chemistry that happens on the surface of these frozen ice clouds in this polar stratosphere. So to cut a long story short, the risk for the northern hemisphere was that you had changes in obviously atmospheric temperatures. A weird possibility, might seem counterintuitive, that you could have a situation where whilst you warmed the surface in the troposphere, you could cool the stratosphere. But that sort of is the physics of redistributing energy. That could, on the one hand, obviously possibly contribute to these polar stratospheric clouds, but also we saw some evidence in some models that the climate change changed the atmospheric circulation, including in the stratosphere, in a way that you might conceivably have got a clearer vortex in the north. Now, I'm not sure, as I said, that we would still argue that now. I might actually, after your question, go back to the literature and have a look at current thinking on that. So that was a great question. But of course, down in the troposphere, we're more worried now in the northern hemisphere about making the jets in the mid-latitudes less strong and having them meander all over the place. So, yeah, good one.
Our next question is from Kevin. I don't know if, Kevin, you said you were eating, so you couldn't speak, but I don't know whether since when you finished whatever you're eating.
But I've actually finished.
Oh, fabulous. Okay, I'll
well, Kevin.
Thanks a lot, Tim. So I was just wondering, you mentioned in the beginning that on many scales, we are changing too slow. You mentioned like 10 times too slow, 100 times too slow. I was wondering about your honest opinion, or if you are just honest about the whole situation, if you think that we can actually make it in the next 10 to 15 years to get the change we need fast enough, or if you think we will overshoot by much.
I'm pretty well. I bet it. If I was laying bets, it'd be a sad bet to make, but obviously I'd bet on us overshooting. But my point is to still have a chink of hope that we don't. The only hope is from finding and triggering the positive tipping points. and I take a little bit of comfort from the examples I give you, because okay, iron and steel production, that one will not be sorted within 10 years, but and it is not trivial in emissions, and neither is cement, but they're not as big as, you know, power or transport or buildings and industry and other parts of industry. And we're seeing real chance to radically accelerate decarbonising power and transport. We're scratching our heads on heating, but it could be done, and buildings, it could be done. It's not impossible. And then for the rest, well, we don't have to sort of solve all the rest by 2030. So yeah, a betting man would have to say almost bound to overshoot, and we might overshoot spectacularly, but I don't want to overshoot, so I'm going to do everything in my power to try and explain how the chance we have left to not miss the targets. The problem, of course, is it's no point me sort of preaching to the converted on that. We need to have policymakers and we need economists who are smart enough to understand this. And economists, bless them, I work with some brilliant ones, but most of them, especially ones who are actually influencing policy, are still stuck in the wrong paradigm. They are looking for maximum allocative efficiency of a finite amount of investment, which is a brilliant way to maintain the current status quo and a really poor way to create transformative change. So we basically have to change the economic paradigm or operational paradigm for decision making towards one way you ask the question, where do I get the biggest transformative change for my buck? Yeah, thanks.
Thank you very much. Final call for questions if anyone else would like to submit any more, but I've got one from Asta, who is also unable to ask it herself, but she's asked, have you seen an impact in decision making and output data as organizations such as the WMO have moved to use Earth system models?
I don't know if there's a spectacularly strong coupling from the advances in climate and Earth system science to the policy decisions. I probably wish there was a strong link, but it depends very much on context. So I think we should be pleased that we have more comprehensive models that start to consider the permafrost. They don't really have the ice sheets in yet, but we get there. But the last few decades would rather suggest that there's a spectacular decoupling between the message coming from climate science and action on climate. I do think that decoupling is narrowing, but I don't think it's narrowing because we made a better climate model. I think it's narrowing because of Greta Thunberg, because of actual observed changes I've talked a bit about in the climate that have been waking everybody up, and a few other factors besides. Possibly a sort of tipping point away from that, finally getting past this idiot situation we were in of climate deniers being given as much airtime by the BBC or whatever as climate scientists, and of course massively powerful vested interests who wanted to sow uncertainty around the central message of climate change. They were very effective, but I think we're finally starting to win that battle, and I think those factors are way more important than I'm proud of the progress we made in the science, but I think they're way more important than the advances in science. Yeah. Benoit is in the LT. Yeah.
I'll just read it out in case anyone hasn't can't see the chat, but I understand that some tipping points occur for tech adoption, for example, car instead of carriage. But is it more convenient? Oh, sorry, because it is more convenient. How to ensure positive tipping points that enable necessary but constraining changes, such as less flights, less goods consumption?
Yeah. Yeah, that's like the $64,000 question. Yeah, well done. Yeah, so a really interesting one, Benoit. And one example I'm working on right now is around diets. Maybe you'll argue that's a slightly easier example than your flights or something. So maybe I should tackle the flights one. But I mean, I was still doing some flying for work. Wasn't really enjoying it before the lockdowns. So thanks to the coronavirus, I think we've had a sort of shift in perspectives of how we work, and I will not be resuming flying afterwards. So I don't think, so I think we could have a tipping point there. Diets I mentioned because that's a classic case where some people seem to feel very, very strongly about eating a lot of red meat. I'm not, by the way, a vegetarian at the moment or anything like that. I would say I was in the broadly speaking flexitarian camp on diet. The point really is, like you say in your question, can we get to a point with diet where plant-based meat substitutes, or if you refuse to have that cultured meat or whatever, can we get to a point where they're as attractive as cheap or cheaper than conventional meat that's clearly bad for our health and bad for the planet? We see lots of signals that we could, that tipping point could be coming. But yeah, some are harder than others. And if we have to pursue a message of this is just about making sacrifices, then we're definitely kind of doomed. So I suppose I wouldn't have articulated this very well in the talk, but I think we need to persuade ourselves that actually we've got a better quality of life sometimes consuming less. After all, like I said, I really wasn't enjoying, like when I would take the occasional long haul flight, I was suffering physiologically. It's not worth it. And why, look at middle America. They've spent, decades since the baby boomer generation consuming excessively. Are they happy buying all this stuff? Apparently not, because otherwise, why would they not? If they were happy, why would they be doping themselves up on OxyContin or whatever other things that some other evil capitalist bit of the economy is flogging them, to put it bluntly? So I don't fundamentally believe in myself, or you make your own decision, but I don't think people are actually happy with the neoliberal capitalist consumptive economy. I'm not. Are you? Yeah, thanks. I'm not alone.
I think so. That looks like it's the last question in the chat. So, but if anyone has an extra one, then feel free to stop me. But I've got one final one to wrap up this talk, and that's kind of following on from Benoit's question in terms of encouraging people to change their behaviour. Do you think that we need to try and get people to understand the dangers of, for example, tipping points in the climate system, or how bad climate change could be? Or do you think people kind of already get that, and it's more about crossing the technological tipping points that mean people make different decisions based on price, for example, of cars?
I think the beauty of people is they're all different. So for some people, scaring the shit out of them with tipping points, it still works. For other people, that's totally demotivating, and it leads to nihilism and despair. And some of you might be in one camp and some in another. So that's kind of why I'm keeping both messages in one package, because different people respond to different things. Would be a sort of shortish answer. I think we're probably doomed if we think that what we have to do is tell other people how to behave. That doesn't have a good history, and it won't have a good future. My point, I'm not sure it came across, but my point with positive tipping points is a deeper philosophical one. It's supposed to give you back a feeling of agency, or what other words can I use? Autonomy, I think, is the best word. So the point is, the world's been totally transformed in its history several times. We wouldn't be here with an oxygen-rich atmosphere to breathe were it not for one tiny organism 2.7 billion years ago evolving what we technically call oxygenic photosynthesis that spits out oxygen as a waste product. That one organism went on to become zillions of cyanobacteria and completely changed the world. You could make the same argument for lots of tipping points in human history, that something that started tiny with just an individual in or a community ended up becoming the thing everywhere. So I'm trying to subliminally, gently say to you all, non-linearity is good, tipping points are good, a messy, complex reality is good, because it's one where we have the agency to begin the change. I mean, just look at Greta. One person sits down out on a Friday outside the Swedish Parliament instead of going to school, and what had happened within 18 months? How many million people were marching on the streets? So we need to get that into our heads. Stop thinking, oh, we've got to tell Uncle Barney or whatever to stop eating burgers or whatever it is. We can take things into our own hands. Yeah, I'm glad I'm getting some smiles in the audience that I can see. And the message from me is a subliminal message about how to see the world and how to see our predicament, and try not to feel totally powerless in the face of a huge and scary thing like climate change, and not just sort of sit back and think, oh, we're doomed because the person X with power, the government or some big business or some other people I've got no control over, are not doing what they should be doing. Well, if they're not doing what they should be doing, let's get out on the streets and do things differently and tell them that we're doing things differently. Let's not just get out and say, change what you're doing, leaders. We should do that. They should change what they're doing, but we've got the power to make change as well. That's what I'm getting at. I hope that's makes some kind of sense.
Yeah, that was a very empowering note to end on. I'd like to ask everyone who can to unmute and give Tim a round of applause to thank him for talking to us today. So thank you.
Thanks for having me. Thanks, Lottie, for setting it up as well. You're the future, kids.